Well, you can do conditional probability by a formula. It's really easier to do it in a way that makes good intuitive sense. Let's take another look at that example. Roll 2 dice. Let A be the event, roll a 1 or a 2 on the first die. Let B be the event, roll a 2, 3, or 4 on the second die. What does the probability of A given B equal? We'll set up our sample space with the first die on the left and the second die across the top. Entries in the table are of the form first die, second die. These cells represent the events 1 or 2 on the first die. And these cells represent the event 2, 3, or 4 on the second die. This is our given. Of these outcomes, these cells represent the ones with a 1 or a 2 on the first die. 6 of the 18 cells are shaded. These represent the outcomes where event A occurs, a 1 or a 2 on the first die, given that event B occurs, 2, 3, or 4 on the second die. So, we can see that the probability of A given B is 6/18 or 1/3. That's a lot easier than trying to figure out how to use the formula properly. You'll find times when you do need to use the formula, but for many of the conditional probabilities in basic statistics, this method will work just fine. Look at that table once again. What's the probability that the sum of the dice is no more than 7, given that one of the dice shows a 3? The probability that the sum of dice is no more than 7, given that one die shows a 3, is 7/11. How about the probability that one die shows a 3, given that the sum of the dice is no more than 7? The probability that one die shows a 3, given that the sum of the dice is no more than 7, is this. Pretty easy, huh?